Hi guys, welcome to Algorithms Made Easy. My name is Khushbu and in this video we are going to see the question single-threaded CPU. So let's go and take a look at what the question says. You are given n tasks labeled from 0 to n-1 represented by a 2D integer array tasks where task of I is the combination of two values NQ time and the processing time, which means that the ith task will be available to process at the NQ time of I and will take the processing time as processing time of I to finish its processing. You have a single threaded CPU that can process at most one task at a time and will act in a following way. If the CPU is idle and there are no available tasks, CPU remains idle. If the CPU is idle and there are available tasks, CPU will choose the one with the shortest processing time, and if there are multiple tasks that have the same shortest processing time, it will choose the task based on the smallest index. Once the task is started, the CPU will process the entire task without stopping. The CPU can finish a task and then start a new one instantly. Return the order in which the CPU will process the tasks. So here we are given a few examples, but rather than looking and reading out the explanation that is given along with them, let's take a look at one of the examples in a graphical manner, which will make us understand this example much more clearly. So we are going to mimic the single-threaded CPU as per the given conditions in the question. For that, let's take a few things with us, which includes the processor itself, that is the CPU, and a clock that is going to tell us the time. The processor will have two areas. One is the processing area, wherein there will be a task that is currently being processed. And the second is the waiting area, where all the tasks that are waiting to be processed will be there. This clock is going to show the current time or the current t at which we are, and then we'll have a task. This represents a task for us, wherein the first value is the NQ time and the second value will represent the processing time. So over here the NQ time is 1 and the processing time is 3. If the clock shows 1, we can happily move this into our waiting area, but since the clock over here now is telling 0, we cannot NQ it right away. So we need to wait till the time turns 1. So now time is 1 unit and this is the NQ time for this task as well. So the task can be moved into the CPU, and since the processing area is empty, this task will move into the processing area. And the end time for this task will be the time at which it entered plus the processing time, that is 1 plus 3, that is equivalent to 4. So till the time equal to 4, this task will occupy the processing area and all the tasks that are coming in by then will wait in the waiting area. So let's see how this goes. Now at time t equal to 2, suppose there is no task coming in. So we'll happily move forward to time equal to 3. Now at 3 there is one task that is coming in, which is 3,5. So this will get NQ'd in our waiting area because the processing area is still occupied till t equal to 4. Now when t is equal to 4, there is one more task that is coming in, which is 4,1. So this also gets NQ'd over here, and at t equal to 4, this task is finished. So the CPU or the processing area becomes empty. Now we need to decide which task we need to pick from these two waiting tasks. So according to the rule that was mentioned in the question, the task with the smallest processing time is going to get picked. Processing time of this is 5, for this is 1. So this is going to get picked and will go in the processing area. Now the end time of this will be the time at which it started plus the processing time. So this becomes 5. Now At time t equal to 5, suppose there is one more task that is coming in with the processing time of 5. It will go to the waiting area and this task was finished, so it came out. Now the processing area becomes empty. So we need to choose one of these tasks. Now over here, the processing time of both these tasks are same. So what we need to consider in order to select the task is the index of that task. Now since we have not considered the index with these values, let's suppose that this came first. So in that case, 3,5 will go into the processor and get processed. The end time will be the current time plus the processing time, which is 5 plus 5, that is 10. Now, at 6, there is nothing coming in. Similar to that 7 pay, there is nothing coming in. On 8, 9 and 10, nothing came in. But at 10, this task got finished. And now there is only one task that is remaining in the waiting area. So now this task will get processed. So this task will take the time 10 plus 5, that is 15 units to get processed. In between that, if there is some other task coming in, again that will go into the waiting area. For simplicity, let's take that this is the last task. And so at t equal to 15, this will also move out of the processor, and this is the sequence in which we have processed the task. So now this becomes the output sequence of the task being processed by the CPU. So now the question that we need to ask ourselves is, what are the data structures that are going to fulfill our need in order to solve this question? Before that, just for simplicity, we excluded the index part from this demonstration. So we need to even take care of that while we are choosing the data structures of how we are going to store these tasks and how this task is going to get picked. So now there are two things that we need to consider to solve this problem. One of them is to store these task data. And the second is the process that we are going to use to pick these tasks. Now, the questions that we need to ask over here are where and how. That is, where to store the task data and how to store the task data. Whether we need a sorting or we can just store as in we are getting. Second is, where are we going to keep the tasks that are to be processed and how are we going to pick the tasks that are to be processed. So these two questions will give you the answer to how we are going to code this particular problem. To store the data, you can either use something that will give you a container to hold all the three data that you need to know while processing a task. That is the index, the processing time and the enqueue time. Apart from that, how we are going to store the data is to ask the question that whether you want to do any ordering on that data. Now, to enter into the waiting area, you need to know the enqueue time. The task that has a least enqueue time will go in the waiting area before the one that has the higher enqueue time. So that says that you need to do some sort of ordering on that data. Now, second question is the process by which you are going to pick that particular task from the waiting area. Now, for that we need to know that what is the data structure that is going to depict the waiting area, because we need to fetch the one with the lowest processing time or the lowest index. This kind of functionality where we want to get the topmost element or smallest element or top k elements or frequent elements is given to us by priority queue. So that is what we are going to use in this particular waiting area part. Second thing is how we are going to access this. On what basis is this priority queue going to be sorted? So this is something that you need to think of. According to the question, the picking of the task depends upon the processing time, and if the processing time is same, it is going to depend on the index. So these are the two parameters on which the priority queue is going to be sorted. So now that we know what are the data structures that we are going to use and what are the things that we need to keep in mind in order to solve this question, let's go ahead and code it. So let's first think about how we are going to store these tasks in order to get processed. So we need a task that will comprise of index, enqueue time or the start time and the processing time. So this gives us how we are going to store the task, and we also need to see whether we need to sort this particular task or not. So sorting will be needed because we need to first enqueue the time which has a lower start time. So sorting will be based on start time. Now what happens when the start time is same? In that case, we need to do a second level sorting based on the processing time. Now the question arises, do we really need the processing time? Because the priority queue will pick the task based on the processing time. But initially when you are putting the first task at that point of time, if there is a task that starts at time equal to 1 and has a processing time of 10, and there is a second task which is at a later index which has a start time of 1 and the processing time of 1, 1,10 will go into the processor first if we do not consider this processing time because we have not sorted it correctly. So for that purpose, we are going to have a 2-level sorting on this particular task. So let's quickly take a class task and try to create an array of this task rather than the array that is given to us, which will be sorted. So this is simply the task class that we are going to have, and now we are going to iterate over the task and create an array of this task and sort it. So this will give us the sorting of the data. Now let's go to the second part of how to pick the task. So for that we are going to take a priority queue, and the sorting on which the priority queue is going to process the task will be firstly based on the processing time, which is going to be ascending, that is lowest first, and if these are equal, it is going to process on the index, which is also going to be ascending order. So for that, first let's take a priority queue. Now what this priority queue is going to hold? This priority queue is going to hold the task. Secondly, what is the sorting that is going to be there? So let's give a comparator over here. Let's take a few more index variables that we are going to need, and then we'll loop on the tasks that we have. Firstly, that we are going to need is a result array that we are going to return, and let's just return that as well. Now there'll be an index for the task that will keep moving, and there'll be an index to put the data into the result that is going to be moving, and both of these are going to be 0. Next, we'll also be needing an end time to see when our next task is going to end its processing so that we can put another task into processing. So now let's take a while loop, and we are going to iterate while my index, that is the task index, is less than n. So I still have some tasks to be processed. In this, there can be two scenarios, whether my waiting list or the waiting tasks are empty or not. So this represents that if these waiting tasks are non-empty, That means I need to process one of the tasks and calculate a new end time. So I need to, otherwise I just need to add the task in waiting list. Now, in order to calculate this particular thing, we need to pick the next task, calculate the new end time, and fill the waiting tasks queue. We'll talk about this part in a moment. Let's first see how we are going to pick the new task and how we are going to calculate the end time. Initially, the end time will be 0. Now, in order to pick the new task, we are just going to get a task from our priority queue. So, the task that we are going to pick is going to be one from the waiting tasks. The remove function will give us the task according to the logic that we have given. So, this current task will have an index that we are going to put into a result. With that, it also has a processing time which will be helpful in calculating the end time. So first, let's calculate the end time. The end time now will be the maximum of either the start time of this current task plus the processing time, or the end time at which the previous task was going to finish plus the processing time for the current task. Correct? So we will write math.max of either current task dot start time or the end time. So this is going to be the time at which this particular current task is going to start, and for it to end, it will take the processing time of this current task. Now we have the processing time or the end time for the next task. Between this end time, we also need to put all the tasks that are coming to us before that into the waiting area. So for that, we'll again run a while loop, but before that, we also need to put this particular index into our result as well. So let's do that. For result, we have a result index that we had taken. While we are adding this, we'll also increment it. Now let's take a while loop. So over here we are seeing whether my end time is still greater than the next task in my task list start time. If that is the case, we are going to add that particular task in our waiting task list or the waiting task queue, and we are going to increment the index. Fairly straightforward. So that will take care of processing the task. Now, if we were not having any waiting task, what we need to do is we just need to take this line and add it over here, because we are just going to add that particular task in the waiting zone. This particular condition will take care of the rest of the processing part. Now, once this loop is executed, there might still be some of the tasks that are there in the priority queue or this waiting task list which are not pulled from the list while this index ran out. So for that, we are going to remove those tasks from the list and add it into our result. So simple while loop. We are again going to fill it over here, and then at the end we are going to return the result. So that's it for the coding part. We are done. Let's run this. And this variable is already taken. So let's take another variable. And it's giving a perfect result. Let's submit this code. And it got submitted. Now, what is the time complexity and the space complexity for this particular approach? Since we are going to sort this data, the time complexity becomes O of n log n. The maximum time complexity is going to be captured by this sort function, which is n log n. Space complexity is going to be O of n because we are taking this task array over here. So in this question, we understood more about how to sort a particular data which is given to us in order to get the results that are required, and how the priority queue works, and how we can do sorting, and how we can create a user-defined priority queue. With this, we also learned how to break down the question and then try to come up to an intuition to solve this kind of problems. So that's it for this video, guys. I hope you liked the explanation. I hope you understood the problem, and if you still have any doubt, please put a comment and we'll try to reply to it. And also, if you have any other question in mind that you want us to make a video, please drop that in the comment section as well, and we'll try to take it up as soon as possible. So thank you for watching, and I'll see you in the next one.